At exercise 13.4 question. Here, proving question, sine theta 2 3 theta 4 theta equals to a 4 cosine theta over 2 and so on. Now you realize that we have 4 terms here, and then what we're trying to do is to transform them into factors. So you can see factors. A times B times C is similar to A multiplied by C, B multiplied by C. We are converting the terms into factors. So obviously we need the factor formula. Right, we'll start from the left to the right. Okay? Right, so the left hand side. Okay, we're going to use the first one and the third one. Right? First and the factor formula. We will have 2 sine theta plus 3 theta over 2, and then cosine theta take away 3 theta divided by 2. So that was set. No? Now looking at the second set, you have 2 theta and 4 theta. We will have plus 2 sine again, and then we have 2 theta plus 4 theta divided by 2, and then we have cosine 2 theta take away 4 theta divided by 2. And then what you have is 2 sine and 2 theta, cosine we have theta. Okay, and then the second one we have here 2 sine, then 2 plus 4 is 6, so you have 3 theta, and then we have cosine theta. Okay, we have the common factor, cosine, as well as the 2. So we're going to take common factor, 2 cosine negative theta, and what we have left inside is sine 2 theta plus 3 theta. Now we look at your page 233, you'll find that your cosine negative theta is actually also equals to your cosine theta, and then we apply the factor formula again. The bracket inside, what you have is that 2 sine, and then we have 2 theta plus 3 theta divided by 2, and then we have cosine theta take away 3 theta divided by, right, let's in we have 2 cosine theta, and we have 2 sine 5 theta 2, and we have cosine negative theta over 2. Okay, you multiply them up, we have 4 cosine theta sine 5 theta over 2, and here again you know that this is also equals to theta over 2. So you will have 4 cosine theta over 2 cosine theta and sine 5 theta over 2, which is equals to your right hand side. Now the second part of the question says you are supposed to find all angles between 0 to 2 pi, right, for this particular expression. So because it is 4 terms, we want to have a product 0, so I'm going to use again we already use a factor formula, so this one is also equals to 4 cosine theta sine 5 theta over 2 and equals to 0. So we have a product 0 here. Okay, so product 0, so which means the first condition here, it will be cosine theta equals to 0. The second one will be cosine theta equals to 0, and then the last one here will be cosine 5 theta over 2 equals to 0. And you solve for the three expression. Over here, okay, here we have theta over 2 equals to pi over 2. So theta equals to pi, which is rejected because it is out of range. If you look at here, is between 0 to pi, means that theta is from 0 to pi, not inclusive. So over here we are rejected, and then from here theta will be equals to pi over 2, which is answer. And then here sine, sorry, we have 5 theta divided by 2 equals to 0 will be 0, pi, and 2 pi. So theta will be equals to 0. We have 2 pi over 5, and then we have 4 pi over 5. Now here again rejected, right, based on given. So therefore theta will be equals to 2 pi over 5, pi over 2, and 4 pi